Hello guys, in the today's class we shall discuss the subtopic of static relays, that is comparators. We know that when fault occurs in the system, the magnitude of voltage, current, frequency as well as phase angle may change their values, and these quantities are different from the quantities which were present in the healthy conditions. So our static relay circuitry is designed such a way that to distinguish any such changes between healthy as well as faulty conditions. Either it may be magnitude of voltage or current or even phase angle between voltage and current are measured by the static relay, so that to detect the fault and trip signal can be sent to the circuit breaker whenever fault occurs. So the part of the circuitry which compares two such actuating quantities, either it may be in terms of magnitude or in terms maybe phase angle, such circuitry is called as comparator. So there are usually two comparators, one is amplitude comparator and the second one is phase comparator. At the first, let us see the amplitude comparator. So as the name itself indicates, amplitude comparator, so it measures only two magnitudes of input quantities and not the phase angle between those two quantities. So one input quantity is called as operating quantity and other input quantity is called as restraining quantity. So whenever the amplitude or you can say magnitude of the operating quantity exceeds the restraining quantity amplitude, then the relay will send the trip signal to the circuit breaker during fault. Now coming to the phase comparator. Here also it is same as that of amplitude comparator. Instead of comparing two input quantities in terms of magnitude, it compares two input quantities in terms of phase angle. So whatever may be the magnitude, it does not depend on that, only what depends is the phase angle between the two input quantities. And such relay will only operate if the phase angle between those two input quantities is less than or equal to 90 degree. This you need to remember. Okay, this will come into action only the phase angle is less than or equal to 90 degree. Okay. Now let us see the types of amplitude comparators. We know that sinusoidal inputs vary during half cycles. So instantaneous comparison between two inputs is not possible because as they are varying continuously for every half cycle. So what we are going to do here is we are going to rectify one of those two inputs, or we can rectify both two inputs, and again we are going to compare. In that way what happens, then we can easily measure or we can easily compare the two inputs when the signals get rectified. By using such principle, there are again some more few types of amplitude comparators. At the first we have circulating current type rectifier bridge comparators, that is also called as rectifier bridge type amplitude comparator. Second one is phase splitting type comparators, and third one is sampling comparators. Okay, let us see the first one, that is rectifier bridge type amplitude comparator. Okay, this is the diagram for rectifier bridge type amplitude comparator. Here we can see that the rectifier, there are two rectifier bridges here. Between that a polarized relay is connected. This is the relay which used to trip the circuit. So such types of relay are widely used for overcurrent as well as distance relay purposes. So you can see that operating quantity as well as the restraining quantity are the two inputs which you are giving to the two bridge rectifiers, full bridge rectifiers. So I0 will help you to produce operating quantity, whereas IR will help to produce the restraining quantity. and then whatever input is given, that is AC is given, is been rectified by this full bridge rectifier as well as this full bridge rectifier. Again it is fed to this slave relay or any thyristor circuit. This polarized relay will operate only when the operating quantity exceeds the restraining quantity. If the operating quantity is greater than restraining quantity, then only what your polarized relay will operate, otherwise it doesn't. So we can have one more figure here. This is with the slave relay, like I told you earlier. We can use one more setup like this with the thyristor circuit. It is very much similar. Here also we have two quantities. One is operating quantity and other is restraining quantity. This is the current transformer which you already know. Again it is given to the what? RC circuit and then given to the thyristor circuit. So first circuit is with respect to slave relay. Again second circuit with respect to thyristor circuit. Okay. Now let us move to the second type of amplitude comparator relay, that is phase splitting type amplitude comparators. Here figure 2.24 depicts phase splitting type amplitude comparator. So here before any rectification, so we are going to split the input in 6 components which are 60 degree apart. 3 components here, again 3 components here. And then it is fed for rectification. So after rectification, 5% signal is smoothed. We are going to smooth the signal for 5%. And then comparison is made by feeding to this relay, so that a continuous output signal is obtained. Again, the operating time of such relay depends on the time constant of the slowest arm of the phase splitting circuit as well as even speed of the output device. So first we are going to split the input into 6 components, 3 here as well as 3 here. You can see how the input is divided into 6 components, and then again it is fed to the rectifier circuit where it is smoothed within 5%, so that continuous output signal is fed to the relay. So again the operating time depends on the time constant as well as the speed of this device. Third one is sampling comparators. So here also the input signals are rectified like we rectified in earlier case, but here instead of rectifying 2 inputs, we are rectifying only one unit, one of the inputs, and then it is compared with the other input at a particular moment. And therefore any instantaneous value of the other input which are not rectified is sampled at particular desired moment, and such comparators are utilized in reactance as well as Moore relay characteristics. Okay, so instead of rectifying 2 inputs, we are going to rectify what? Only one of the inputs, and then it is compared with the other input at any particular moment. So the instant value of other input which is been not rectified is sampled actually at any particular desired moment. So one input is rectified and other input is sampled for any desired moment, and then they are compared. We will learn in detail in the coming chapters.